Bismillah ar-Rahman ar-Rahim. This is the chapter 1, exploring the network. So it provides an overview about what networks are and why they are important in our daily life. So these slides, of course, provided by Cisco, and I modified most of these slides to be suitable for our course offering. So these are the topics covered in this chapter. So we'll talk about how network affected the globalization of the internet. We'll talk about important concepts like what are the differences between LANs and WANs, what are these? We'll talk about a network as a platform, and then changing the network environment. So we'll go through these topics one by one. So as we know, the internet has affected our daily life, and it actually intervened with just about every aspect of our life. So that made the growth of devices and the usage on the internet to double every few years, and it started with the small concept that we need two computers to share a certain resource. Like, instead of having one printer in every computer, we need to have like a printer that everybody prints to. It's a very simple objective, but actually this objective evolved very rapidly, that now internet facilitates the communication between people, facilitates the communication between people and environment through certain devices that capture some. So people use it for medical applications, they can use it to monitor their state and so on. And that's what we call Internet of Things. So now we are close to this part now where we have almost 10 billion of devices on the internet. But this is expected to continue growing, and everything on earth is going to be connected to the internet. So the tables, our clothes, our fridge at home, TV, everything is going to be connected on the internet. And this is what we call Internet of Things. So everything is going to have an IP address. It's going to have some level of intelligence that will be used to facilitate the communication between two people, facilitate the communication between people and environments, and devices to device communication, and so on. So because of these sophisticated technologies, now we can have a meeting around the globe that includes people from different parts of the world, and we can talk to each other as if we are face to face. So using these technologies from Cisco, different people around this table are existing on different parts of the world, and they can see and they can interact with each other, and even using some kind of handshake and so on and so forth, and they can communicate as if they are communicating face to face, and that's facilitated through the sophisticated technologies of networks. So with that said, the networks affected every part of our life. It affected the way we learn, it affected the way we communicate with each other, it affected the way we work. So now different organizations can actually rely on networks to, like for example, to monitor traffic, to monitor manufacturing process, monitor people in some cases, monitoring other devices, and so on and so forth, monitoring the environment, and so on and so forth. It affected even the way we play. So we have seen the VAR in the last World Cup. It actually changed dramatically the way that these games can work. In some cases, it affected dramatically the end result of the game. Okay, and that's because of the sophisticated technologies of networks. So now we can record everything, we can monitor everything, and we can provide distant and remote communication between people. So distant learning, for example, can allow an instructor to give a class to people who are remote. In fact, we use this frequently here. So sometimes we go on a conference and we give the class while we are in the conference. So we can connect remotely on Skype or something like that, and we can give the class as if we are giving the class face to face. So in short, networks affected every part of our life. It intervened with every part of our life. So now, whenever we walk around, we see signs like we have Wi-Fi here, or we have cyber internet service in this coffee shop or in this shop. So all these signs have been made available because of the technologies of the internet and the way that networks work. So these networks can be used in a small room, or it can span the entire globe, or it can be worldwide. So we can have very small network at home, which facilitates the communication between the household people, or we can have it in a large building to facilitate the communication between different devices in the same building, or we can have it in a small office, or between people in different countries, or in some cases in different continents. So all these types of networks, they use the same kind of software and algorithms and things like that, but again, there are some customization and differences between these types of networks which we need to study. So what are the main issues that exist in these different sizes of networks that make these networks work efficiently regardless of their size? And this is a very important feature of these networks, that regardless of their size, whether they span a room, a building, an office, or a country, they need to work seamlessly and in the same way as much as possible. Okay, so what are the design issues and aspects in these networks that allows them to cover different geographical areas like this? So this is from the network coverage point of view. From the application point of view, we know that we have two very important architectures. We have clients and servers, and we have what we call peer-to-peer. So client and server is based on the fact that many people, they have what we call a client application. This client application, the definition of a client, and again, some students they get confused. The definition of a client is the entity that always initiates the communication, requests a service, okay? And this service is requested from the server, okay? So many students, they get confused with the fact that the client is the one that sends communication, and always the server is the one that sends back the answer. And that's not accurate, because the service that I'm requesting could be to upload something on the server, or it could be to download something from the server. But I'm always the one, the client is always the one that initiates the communication, okay? So the server is always waiting, okay, for the client to request something. So a server serves many clients, hundreds, and in some cases thousands of clients. An example of this is the web server, or when we say www.google.com, our browser acts like a client. It connects on a server in Google. So you can use that example on every software that we use in our life. So you have a browser which acts like a client. You can use a service like FTP. You can download or upload files from a server or on the server. But the client is always the one that initiates. starts the communication. Server never starts communication. So this is the main difference. Okay. So a client-server architecture is based on the fact like you have many clients and you have one server. So it's a many-to-one relationship. Okay. Always the client initiates the communication and always the server provides a service based on your request. So that's how it works. As we said, as an example, the email server. So the email server in QU. So we connect on this email server every day to browse our emails. So our software acts as a client, connects to the email server, fetches the emails, and then we can see the emails. Same thing on the browser, same thing on different other software. File server like FTP, and so on. So that's client server. Do we have another architecture? Yes. Not in all cases that we have a client that always initiates or requests a service and the server responds back. Why is this? Because the server in that case acts as one point of failure. If the server is not working correctly, all these clients are doomed. They cannot work. They cannot communicate to each other. They are communicating even to each other through the server. Okay? So if the server is not there, you cannot do anything. Okay? So it acts as a single point of failure. The other thing is that the client itself is a very lightweight entity. It does not really have a huge amount of database or file content or something. This exists on the server, and the clients are usually very lightweight. They do not host anything. But the server is the one that manages and hosts all the content. Okay? Then the client can upload something, can upload one file to the server, and the server is always the host that maintains and manages all the content. So that's why it's a single point of failure, because if it's down, we cannot access this content by any means. واضح كده? Okay? So, do we have another architecture? Yes. There is what we call peer-to-peer. In that case, peer معناها we are equal. Because in the client server, they are not equal. The server is the one that manages and hosts everything. Right? In peer-to-peer, no, there is no server. All of us are clients and server. So I can act as a client or a server. I have some content, you have some content, everyone has some content. No one has all the content. No one. واضح? So no one has all the content, like in the case of client and server. An example of this is اللي هو BitTorrent or Gonatella or eMule if any of you have used that software. So BitTorrent does not host anything. BitTorrent facilitates peer-to-peer communication between different people all over the world. I have some files, you have some files, and we can at any point share these files if we so desire, but there is no centralized host. So everything is distributed. So for client and server, the content and the management and everything is centralized in the server. Okay? The server can choose not to accept a request from a client. So the server is the main controller of everything. Managing the users, hosting the files, managing everything. Okay? In peer-to-peer, no. In peer-to-peer, we don't have to have a centralized host and management entity like the server. Peer-to-peer is distributed. All the peers are distributed, and everyone hosts certain part of the content, and we can share it based on certain rules and certain policies that we can design. So it's easier to set up in the sense that I don't need to connect to a server and have a user ID and password on the server and so on. No, I mean, we are peers. We can communicate at any point in time. Once you have the software, you start it, your device will become a server and a client at the same time. A server, because I host some content on my device, and others can fetch that content from my device. And also a client, I can also fetch content from another device. So my device technically acts as both client and server. So the rule that we set for the client, that the client is always the one that initiates the communication, it does not necessarily hold here. Anyone can initiate the communication at any point in time. واضح? So it's less complex in the sense that, again, it's not a single point of failure. It's low cost because I don't have to have a server that hosts everything, because as we can imagine, if we have a host that hosts everything, the scale of that host is extremely large. So in that case, I have to have a huge machine, very powerful, huge amount of storage in order to host these files. But in peer-to-peer, I don't have to do that. My device can act as a peer, can act as a server and a client at the same time. I don't have to host everything here. I can host some, and others can host some. The disadvantage of peer-to-peer is that there's no centralized administration, which means it's ad hoc in a way. So anyone can connect on anyone. There is no restrictions. And that's why BitTorrent and these things are very hard to control. Very hard to control. So it's growing very rapidly. So there are millions of people who are using BitTorrent. And you cannot control who is accessing what files on which device. You cannot have this information because it's totally distributed. There's no one server that hosts everything and manages everything. So again, centralizing the management and hosting of the files, sometimes it's easy to control, right? So I can, if I want to control or manage or perform any task on the database, I can just connect to the server and do everything. But in peer-to-peer, there's no such thing. It's distributed all over the world. So I cannot really control things easily, right? Not as secure, of course, because again, I cannot control the server. If I have one server in one location and it hosts everything, I can make it secure. I can implement and set up all the security issues on this server. I can make sure it's secure and so on. But for peer-to-peer, secure what? I have tons and thousands of devices. I'm not sure, I cannot control the security of these devices, right? And that's why BitTorrent is the source of most of the viruses that we have on the internet, because there's no control. You can connect on any device and download any files and you harm your device, and then your device will become a source of attack to other devices and so on, and that's how the viruses spread widely. So as we said, all devices act as clients and at the server at the same time. So it's more complex in that case. So the peer-to-peer software is more complex than just a client. So the client is always the one that initiates communication, and it does not host content usually. So in that case, it's very light, very simple. But now with peer-to-peer, it has to be slightly more complex, and it has to be more intelligent, because now the device itself acts as a client and a server at the same time. So it needs to be more complicated. واضح؟ أي حاجة مش واضحة؟ Okay. So these are the two main architectures on the internet. So on the internet, you can classify most of the software that we use using these two architectures. Either client-server, so you have software on your device that acts only as a client, which means that the client is the one that initiates communication and requests service from the server. Or you can have peer-to-peer, like BitTorrent, Donatella, all these devices, they can act as peers on the internet. Type. In terms of network coverage, as we have explained before, the networks are divided into three different major things. You have devices, which are the physical entities that are connected together. By physical, I mean like a device, like a computer or my cell phone or something like that. And you have media. Media is like the cables, again, physical cables. And these cables are used to interconnect the devices together. Okay, and these cables can be made using copper, okay, like coaxial cables, like UTP cables, as we will see in the lab. Or it can be even wireless. So wireless is a type of media, a type of physical media that is used to connect devices together. Wireless, we talk about the air environment, and we use that to send some wireless signals as energy that transfers from one place to another. So that's a type of physical medium as well. So we have devices and we have media. So those are physical things that exist. But we have also services. Services are software that runs on these devices that facilitates the communication. These services are the applications that we have on our devices that facilitates the communication through the physical medium to send the information from one place to another. So in a way, the services are the glue that connects the devices and the cables to facilitate the communication. Okay? So these are the major components of any network. So to go through these, so you have end devices like computers, like workstations, laptop. My cell phone is an end device. End device is the one that interfaces the user to the network. So any type of device that you use, even this is an end device. This is an end device. That's an end device because the user uses that to communicate on the network. So that's the end device. The voice over IP, the telephone set that we use to communicate voice, that's also an end device. Security cameras, telepresence endpoints, which is the meeting that we have seen. It's called telepresence. So these are used again as end devices to facilitate the user interaction to the network. So anything that interacts with the user is an end device. Well, so mobile handheld devices like iPhone, like Galaxy Note, and so on. And there is the infrastructure devices. Infrastructure devices are not used to facilitate the user interaction directly. These are not seen or not to be operated by us. Okay? These end devices are devices that work behind the scene to connect the end devices together. Like network switches, like routers. So we know that these devices, they exist, but where? We don't use them. As users, we don't use them. And in many cases, we don't even see them, but they are there. Right? So we know that in ITS, there are tons and tons of these routers and switches. Without these routers and switches, we cannot communicate. We cannot have computers that communicate together. Right? So these intermediary network devices, or we call them infrastructure devices, these include network access devices, like we have we have this device. This device. This is like a Wi-Fi access point. Okay? So we don't use this device directly. We use this device through our end devices. But we know that this is an infrastructure device that has to exist in order for our end devices to work. Right? Without these, our end devices cannot send anything on the network. Right? So these are isolated, and without these kind of infrastructure devices, our end device is isolated device. It cannot be used on the network. It cannot communicate anything on the network. واضح? So these network access devices, like switches, wireless access points, inter-networking devices like routers. So throughout the course, we will talk in details about the differences between switches and router. What is the difference between switches and routers? And we have security devices. So I think most of us are aware that we have like firewall. Firewall prevents any illegitimate requests to come into the network. Otherwise, the network of the university can be hacked easily by someone from outside. They can get all the information. They can destroy the network. They can cause the network to be down for a long time, to be not available for a long time, and that's a huge harm. So these are the two types of devices. So we have end devices and we have infrastructure or intermediary network devices. So this is the difference between the two. واضح كده؟ تمام. The second component, which is what we call the network media. The network media can be made of copper, and we will go through all these different types of cables. So we have UTP. So we have the type of UTP cables, and we have what we call coaxial cables. These are made of copper. Okay, and we'll talk about the characteristics of these cables. What is the difference between these cables and, for example, fiber optics? So the copper cables, they can be used with electric signals. Fiber optics, they use the light. So we can use the light to communicate. Fiber optic is a type of glass. Okay? And glass is used to reflect. It's used like mirrors to reflect light to go into a certain direction, and based on this light signal, we can move information from one place to another. So the copper works with electric signals, fiber optics work with light signals, wireless work with microwave signals. Microwave signals are like signals that can travel through the air and move the energy from one place to another. And based on this signal, we can capture this signal using antennas, like the TV, like all our wireless devices, they have antenna. If you don't see it, it's actually built in. And it captures this wireless signal and then converts this wireless signal into digital data that we can use. So these are the three major types of media. So we have copper, fiber optics, or wireless. واضح? So we'll talk about them again in more details. So what are the characteristics of the copper cables versus fiber optics versus the fact that they use these different types of signals? It makes these media to have certain characteristics. So what are these characteristics? Like, for example, range of communication. Like, for example, interference. They can be interfered with other things, and so on. We'll talk about these characteristics later. So based on that, these physical devices have certain symbols and representation, and it's very important for us to be familiar with these symbols. Okay, so throughout the course, we will very frequently use these symbols, for example. So we'll very frequently use these symbols to indicate this is a switch, this is a router. Mainly switch and router are the most important. The rest are not that important. But we know we need to be familiar with the symbol of the switch and a router. So when we see this shape or this shape, we know that this is an intermediary network device or an infrastructure device. Versus these symbols, which are very, very logical, and we are all familiar with them. So we have a desktop computer, we have a laptop, iPhone, all these are end devices. And these are to be used by the users directly to interact with the network. And more importantly, these are the symbols of the different media. So this is wireless. So wireless is usually represented using this symbol. So when we see this symbol, this means that there is no physical cable actually, but it's wireless medium. Okay, and there's LAN media and WAN media, and we'll talk about the difference between LAN and WAN in a minute. Any questions so far? Okay. These are the physical components. So when we connect these devices together, we have what we call a network topology. A topology is a certain formation of all these intermediary devices and how they are connected with the physical cables. So this is what we call physical topology. Topology is like a certain network that includes certain number of switches connected in this shape. They have a certain shape. Because based on the area that this network covers, the topology might be different. If I have a network that covers a lab, it should have a certain physical topology. If I have a network that covers a building, the topology will become more sophisticated. If I have a network that covers a university, okay, the topology will be even more sophisticated and so on. Well, so the topology is the interconnection between the devices and the cables, okay, in a certain shape. And this shape can, as we can imagine, it can take thousands of different configurations. That's what we call a topology. Meshi? So a topology talks about a certain shape of interconnecting the end devices and the intermediary devices using cables. So this is the physical topology. There is something called the logical topology, and usually students have a little bit difficulty to have a certain perception between the physical topology and the logical topology. And if it's not clear now, don't worry, because it becomes clearer later on. A logical topology is the same representation of the physical topology, but in a logical sense. So when we start to study how these switches and routers work, we see that this switch, for example, facilitates the multiple communication of more than one device using a logical bus. عارفين الباص اللي هو بتاع اللي في الكمبيوتر architecture? What is the meaning of a bus? A bus means that anything on this bus can be listened to by any computer. So in other words, there's no isolation between these computers. Anything on this bus is received by all these computers. And anyone who sends anything, it goes through this bus. If there are two people sending on the bus, that might be a problem. Right? Because now we have two pieces of information on the bus. So which of them is the one that needs to be communicated to others? This is a question mark. So in many cases, if two of these computers send at the same time, we call that collision. We cannot communicate this way. So we have to make sure that only one computer sends on the bus at one point in time. That's the same thing in computer architecture. If any if the CPU sends anything on the bus, then no one else can send. Everybody can listen, but no one can send. So in other words, it's one talk, many listen. Okay? So later on, we will figure out that the physical switch can be used as bus. So the physical switch actually acts as a logical bus. So when we see logical topology, we should not expect that we go to ITS and see buses everywhere, buses everywhere. No, you will not see that. You will see the physical topology. So this logical topology is just a logical representation of this physical topology for us to understand how these computers can communicate, the way they communicate. Okay? Because that's not clear from the physical topology. But the logical topology indicates the way that these end devices can communicate. For example, as I said, one talk, many listen. You cannot have two people talk at the same time. All of these cannot be reduced from this physical topology. When I see the physical topology, I don't know. I don't know how these communicate, how these devices communicate. But when I see the logical topology, and I see that this is a bus, this is the router, this is the symbol of a router, which means that this network is totally isolated from this network. Totally isolated, which means that I can have someone talk from here, one talk from here, at the same time they go to the router, and the router will get the two pieces of information and will send each one based on their destinations normally. So there is no collision between the communication from these two networks. So that's how the logical topology represents the physical topology. So again, as I said, if it's not clear now, it will become clearer later on, because we will know that easily a switch converts as logical bus. The router remains as a router to facilitate the fact that you can have isolation between these two LANs or these two networks, and they can, in fact, communicate at the same time using the router. Okay? So later on, we will study this more clearly. In fact, we will learn how to, I can give you a physical topology, and I'll ask you to convert it to logical, or the other way around. Okay, so we'll have some exercises how to do that. So we'll learn this more later. Here, from the physical or logical topology, I can say that this part is a LAN. This part here is a LAN because it involves one switch. This part is a different LAN because it involves one switch. Okay? When I connect a LAN to a LAN using a router, this is what we call a WAN. Okay? Type. So we have different types of networks based on the sizes or based on the area that this network is meant to cover. Okay? So we have something called logical area network or LAN. LANs are meant to cover small geographical area. Okay? And LANs are only using switches only. There's no router. Once you see a router, this means it's a different LAN, which is this one. Okay, so usually LANs are used to cover a small geographical area. For example, a lab. 20 computers are connected to a switch. They cover a lab. So that's a LAN. Okay, and we have a LAN here, LAN in the lab next to us, and another LAN, and so on. Connect all these LANs using routers. We call this whole network a WAN. So a WAN is wide area network, which is meant to cover a larger area, usually a building, or multiple buildings. Okay? There are some other types of networks which are less important, and we will not deal with them that often, which is like metropolitan area network. You can think of a metropolitan area network as a WAN. Okay, so it's an interconnection of multiple LANs, but usually it's an intermediary size between the LANs and the WANs. And usually we call actually the MAN, we call it a WAN in many cases. Okay? So in many cases we call the MAN, we call it a WAN. So anything other than a LAN is simply WAN, which is an interconnection of LANs. That's basically what it is. But we have wireless LANs. So the LAN that we have seen, these are wired LANs, which means that there are physical cables that interconnects these devices. If these use wireless, then it's a wireless LAN. واضح ماشي? And there is another type which is storage area network, which we will not get to. These are not used to connect computers in that case. These are used to connect مثلا storage devices only. So they are used to connect storage device to make this storage bigger. Like for example in clouds, in cloud computing and stuff. So they connect multiple storage units to make them look like one huge storage. Okay? But again, these are not used for user interaction or user communication. These are used only for storage. And again, we will not deal with them that often. So this is the example of a LAN. As we can see, we don't have a symbol of a router here. Once you see a router, this is not a LAN. This is the termination of the LAN. So if I have a router here, and I connect the switch to a router, so I call this a LAN, but it's terminated by a router. Okay? So if I connect another network here with the router, I cannot call this a LAN. I have to call it a two LANs, or interconnection of LANs, which is what we call a WANs. So that's what I'm talking about. So once we see a router, I can call this a LAN, I can call this a LAN, but the interconnection of these LANs is a WAN. واضح كده؟ So that's the internet. We'll stop here. We'll stop here and continue next time, inshallah.